Hey everybody, welcome back to the channel. Today we're going to spend a little bit of time here on Laser University 101 level. We're going to talk about the relationship between speed and power when it comes to your laser cutting, laser engraving, etc. Now, I want you to think back to when you were a kid. This is why I have this little guy here. So we have a candle, we have a flame. We've probably all done this little trick here where we run our hand back and forth through the flame and like, look, you know, I'm not hurt, it doesn't burn me, right? So when you did this, you learned that as long as you're going fast enough, you're not gonna get burnt by the flame, right? Now, if I were to hold my hand here, i.e. lower the speed, I would definitely get burnt. So you don't have any control over the relatively low power of this candle, but you can control the speed at which the candle interacts. Now, if I could flip this upside down, like this was a laser, and then my hand stays stationary, you know, depending on how quickly I move the laser over the area, then that impacts how much effect that it has. So there's that. Now, what if I could increase the power? Now, I wanted to get a blowtorch. I don't know where. I looked all through my garage. Probably one of my kids took it. So we're going to use this lighter, which you can barely see the flame, but it produces a much hotter flame than my candle did. Now, I don't want to mess around. I'm not going to burn my hand. But again, we think about this as like a higher power candle. I would have to go much faster in order to not burn my hand, right? More power, higher speed, I cannot get affected. But obviously, we're talking about laser cutting and engraving, so we're not trying to avoid burning or cutting things. We're trying to do just that. So, although your laser beam, we talked about in the last episode when we were looking at focus, you know, the beam of the laser actually travels at the speed of light. So speed isn't an issue there, but it does actually take a little bit of time for it to heat up the material that it's interacting with, right? So most of the time what we're looking at, we want to completely remove the material, i.e. in cutting. The complete removal of that material is a term called ablation. So there's different ways that you can ablate things, but we're talking about ablation through laser energy here. So that's normally what we're looking at. So we're going to do a little example here, and I'm going to walk you through it. So we're breaking out the good old whiteboard. What I want to do is, let's assume that our laser produces a dot, and this is all for simplicity's sake. Let's say that our laser produces a dot of 1 millimeter by 1 millimeter square. Now obviously this square is bigger than a millimeter, but I'm dealing with kind of an older marker here, so I can't make things super tiny, right? So let's say this is the dot size that our laser produces, 1 millimeter by 1 millimeter. Now, in reality, it's actually not quite a tenth of that, but 0.1 millimeter for a 2-inch lens. So let's say that in order for my laser to cut through this 3 millimeter thick piece of plywood, it takes 3 seconds. So after 1 second, we've cut through a third, and another second we cut through another third, and then in that final second we are able to make it all the way through. So let's say it takes 3 seconds for me to cut all the way through that piece of material, right? So if we were looking at this from the top of my material, I would now have a hole completely through. I could see the other side. It took 3 seconds to do that. Now, if my head, my laser head then moves over, so initially my laser head was right here, my laser beam was coming down. Now, if it moves over say another millimeter. So now my laser head is here. And then I fire my laser and we go 1 second, 2 seconds, 3 seconds. And let's assume that these are right next to each other, right? I've now cut this way. So, and again, as a cross section, 1 second, 2 seconds, 3 seconds, right? So I'm cutting this direction. So eventually I want to have, you know, if this was the top here, I'm working to cut this in half, right? So again, in my example, in 3 seconds, it cuts all the way through, head moves over 1 millimeter, another 3 seconds, it cuts through, right? So in this example, I am cutting at a speed of 1 millimeter every 3 seconds, or I'm going to shift this over, 1 millimeter per 3 seconds. This is 0.33, and obviously that's repeating, millimeters per second, right? So now speed. Let's bring speed into this equation. We're starting to talk about speed at this point. So what if we increased the speed but kept the power the same? Well, let's take a look at that. In that example, remember, it took us 3 seconds to cut all the way through. So here's my, move that back, make sure that you can see. Here's my piece of wood. We're looking at this from basically the side view. Let's say that I increase my speed, but I keep the power the same. And now let's say instead of that 0.3 millimeters per second, let's say I increase to 1 millimeter per second. But again, I'm keeping the power the same. What would we expect to happen? Well, as we saw in the first example, I only have 1 second, so I'm only going to get 1 millimeter deep. Then my laser moves over. My laser head is traveling this way. I'm going to cut another millimeter deep, on and on and on. So eventually I'm going to have a line that goes through, you know, again from my top view, I would end up with this line that goes across, but I'm not cutting all the way through. I'm only going in 1 millimeter deep. So now this is equivalent, instead of cutting, I'm now engraving, or I think the Glowforge community, there was a setting called scoring, right? So scoring is just to put a mark in something. So now I'm not cutting all the way through, I'm scoring it, or engraving it. Now, if we were able to increase the power, right? Let's say, again, here's our side view. If we can increase our power, so power goes up, speed is the same at 1 millimeter per second. But let's say we could increase our power to where it only took 1 second to go all the way through. Well, what would we have achieved then? Now we are cutting again. We can get all the way through, and now we can cut at 1 millimeter per second, right? Now you can see, if we keep increasing our power as we increase our speed, we'll be able to continue to cut. Now obviously your laser has a maximum power, right? And we'll cover later on in a different lesson on the maximum power and your tube and all of that kind of stuff. But eventually we're going to max out. There's only going to be so much power. We'll just, for clarity, we'll say we get to 100% maximum power, And again, you know, it depends on the wood, it depends on what you're trying to cut or engrave, etc., etc. But eventually we're going to run out of power. So after a certain point, there is, as we increase our speed, we are no longer going to have enough time to cut all the way through. And so then that's when you start talking about, well, now I need to either change my focus, or maybe I need to make a second path or a second pass. So now the first time I went through, I was able to cut this far at a certain speed. Now I'm going to make a second pass and I'm going to cut the remaining material out. So let's talk about that relationship for speed and power. Okay, so speed and power, because I think charts make things, they help make sense sometimes. So now this is, again, non-scientific, it's just for an example. We've got speed down here, we've got power over here. If we've got low speed and low power, you know, depending on what it is that we have underneath our laser, we might be able to make some effect on that. Maybe it's a, you know, very light mark, engrave, burn, etc. But probably not too much at really low power. So if we keep our speed low, but we increase our power, you can see it's getting darker and darker and darker here. Eventually we're going to, now this line, probably should have found a better way to show it, but eventually we'll be able to cut all the way through, right? So as we saw in our last example, low speed, high enough power, we are going to get past the engraving point and we are going to cut all the way through. Now as we increase our speed, it is, even if we maxed out on power, eventually we are no longer going to be able to cut. And that's why I've had this line here and say that, you know, there's a cutting range. Eventually you're not going, if you increase your speed, you're going to max out on power, and you'll no longer be able to cut. But it kind of gives you that idea that, again, low power, low speed, you're not going to have that much effect. As you increase your power, you're going to get darker engraving. But as we increase our speed, we're going to reach a point at which we're just not even keeping up. And if you go fast enough, no matter what your power is, the laser is not in contact with one particular spot on the material to have any impact on it anymore. So again, a lot of generalizations there. You may find that, hey, for, you know, if I take a piece of plywood and I put my laser on the absolute lowest power, no matter what, it's always, you know, making a mark. So just because that's, you know, again, this is not scientific. I'm just trying to get you to have the basic understanding that eventually you can go fast enough to where you're not going to have any impact. So it's not, some people think that, well, you know, hey, I want this darker, so I just cranked up the speed and I cranked up the power. Well, they work at opposite ends. So yes, cranking up your power, if you kept your speed the same, you would either engrave, potentially, you could be engraving darker, or you're just cutting straight through, so you actually have less, there's no material there, so you're not actually changing color. We'll get into defocusing here in a bit, but let me show you these examples here. So this is an engraving depth test card, and as you can see, what we have here is we've got our speed, so at 200 millimeters per second, 180, 160, 140, and 120, and then this is the power level that the laser was set at, so 15 all the way up to 35. Kind of a higher speed here, 200 millimeters per second, but at a lower power, 15%, I have this very light engrave, and you can see, keep the speed the same but increase the power. I'm getting slightly darker here. It's actually engraving deeper. If you could feel this, you'd see that there's a depth to this engrave. And again, same thing. If I keep my power the same but I slow down my speed, you can see that I'm getting darker and I'm also getting deeper. And then at the slowest speed and highest power, so again, if we come back to this chart, not slowest, obviously 0 is slowest, but on this card, slowest speed, highest power is my darkest, deepest engrave. Now, if I kept going slower and slower, I would be into this cutting range. So here we have, you've probably seen these before, but a lot of people don't, they may run these and they don't even necessarily understand that relationship, and they're like, why didn't all the circles fall out? Is there something wrong with my laser? Well, again, if we look at our power, here we've got 20 up to 40, and then my speed, and you'll see that these speeds are much slower, right? So low speed over here. Let me reposition all these things. So low speed, 10 to 30, roughly very similar power ranges, but that low speed I enter into the cutting range. Now obviously these are different materials, so it is a little bit apples and oranges, and then these higher speeds I'm kind of in that engraving zone. So here my slowest speed, 10 millimeters per second, at 20%, there wasn't enough time and power. You can see the trace, it was starting to just barely break through there on the back side. But for this particular, this is like a kind of like MDF backsplash board, so it's very dense. 10 millimeters per second at 20% power, didn't get all the way through, but at 25% I did cut through, and then beyond that I'm just using more power than I need, so decreasing the life of my tube for really no gain. Where I do gain is if I am able to speed it up. If I can cut at 15 millimeters per second, then obviously it takes less time to cut out whatever I need, but I gotta crank things up to 40%, which is actually beyond the normal safe working zone to maximize the tube life for my particular laser. So really, optimally, I want to be at 10 millimeters per second at about 25% power for this particular wood. So this is why doing these test cards is so important. This would not necessarily be the same if I used this type of wood. I might be able to cut at 15 millimeters per second at 20% power, because this plywood is less dense than this wood. So very important to do your test cuts. So the last thing I'm going to cover in this speed and power video is how focus impacts this. So we already talked about focus in the last thing, but we were talking about being in focus, right? If you remember back to this example here, we have our laser beam and it's converging, and we get to this point where the beam is the smallest. Well, sometimes it might be useful to slightly defocus. So let's say we're going to operate, out of focus by a millimeter or two. That's going to increase our spot size, which could give us, instead of ablating and completely removing that material, we're actually now spreading that energy out over a larger surface, which is actually going to burn the material. So it may give us a darker engraving. Now what you have to realize, kind of come back to our board here, when we spread, instead of having that pinpoint of a perfectly focused lens or distance, and we're spreading that out into a bigger spot size, we're putting the same amount of energy into a bigger area here, so we're burning instead of ablating, which gives us the potential to have a darker engrave, but we're going to lose detail. Now, if this was a finer, if I wanted to do really fine, articulate engraving or letters or something like that, then that's a bad example. The thinnest pencil, marker, etc., is going to be better. Obviously, this would be a better example. This is a nice focused line versus this one. There's only so much detail I'm going to be able to get if I'm slightly out of focus. But if you're not doing something super intricate, then maybe that benefits you. So hopefully that was helpful. And now you can see where potentially a defocused beam could benefit you by changing the characteristics of your engraving. Now in a future video we're going to talk about the resolution or the lines per inch and how that factors into all of this, which is very important when you start talking about defocusing. So lines per inch, or LPI, will be in a future video. Hopefully that was educational for you. It's the whole goal of Laser University 101. If you enjoyed what you saw today, please go ahead and hit that like button, subscribe to the channel, and let me know in the comments if I made a mistake. That's fine. I'm far from an expert. I'm learning as I go. But hopefully you've learned something. I've learned something. Let's learn together. So until next time, let's keep learning and burning together. Take care.